All right. Practice quiz number 3. Let's go over some solutions. Um, all of these are just asking for setups. I'm not actually asking for the volumes themselves. The setups here are the most important part. I'll clean them up a little bit, maybe. I guess we'll just sort of see what happens. And whatever I do is probably what you guys should also do. You can do either shells or discs and washers. I'll, depending on the problem, I might set them up one way and then also do sort of run it back and set it up with the other. I'll definitely talk about kind of for each one, sort of which method is best and why. But let's just jump right into it. So we've got 4 of them here, and we'll do as many videos as we need to do. So 1A is the region bounded by y equals x squared plus 1, y equals 0, x equals 0. This just means that you're in quadrant 1, right? I say that, but technically that's not necessarily true. This and this and x equals 3 would tell you that you're either in quadrant 1 or quadrant 4. So even that doesn't necessarily tell you that you really need all 4 of these things together. Technically, for your solutions for full credit, you don't need a sketch, but having a sketch, honestly, at least for me, I need it to be able to figure out what's happening. So my guess is you'll draw a sketch or sort of get a sketch from Desmos or something, which is fine. Use those tools while you have them to be able to sort of draw these. So I'll just do a quick sketch for us here, just so we can kind of visualize what's happening. So we said x is 0, y is 0, x equals 3, and the function is x squared plus 1. So that's just going to be our standard parabola, but it intersects the axis at 1 instead of at 0. It doesn't go through the origin, right? So it's the standard parabola, just shifted up by 1. Going from x is 0 to x is 3. So if you think x equals 3, 3 squared plus 1 is 9, plus 1 is 10. So if we kind of go out, 1, 2, 3, this one needs to go up to 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll shoot for that. And again, I'm just going to sort of do a pretty loose sketch here. Only for the region between, right, x equals 0, y equals 0, and x equals 3. So I'm not going to bother drawing like the left hand of our parabola. Right. So there's x equals 3. This is set up y equals x squared plus 1, and the rotation for us was around the x-axis. So conceptually, what I'm going to suggest here is slicing discs. That's best because we have, right, y equals type function, and we're going around the x-axis. In general, right, with sort of those two things as our setup to get us started, probably like a disc and washer type is going to be best. So that means our volume should go, right, whatever the interval is, a to b. We're going to do the pi r squared style, and it's going to be with respect to x. So our interval, right, so the region we're talking about is like this, rotated around. So we're going from x equals 0 to x equals 3. It's dx. Everything is with respect to x. So the interval that we're going over is x is 0 to x is 3. The radius here is just going to be the height, which is just following that curve the whole time, right? It's just following the x squared plus 1. If I, do a slice like this and I rotate it, right, that radius value is just going to be the height of the function, and we're totally good. So this will be, right, pi quantity x squared plus 1, right? Quantity squared, integrate it with respect to x. That's the setup. That's kind of good enough. You could do something where you expand it if you want. 0 to 3, right? X squared plus, FOIL this out, plus, or no, this would be what? X to the 4 plus 2x squared plus 1 dx. Either of those is fine. I'm not super particular. This way you can kind of see exactly where everything is coming from. This is kind of the start of the steps that you would do to actually like find the volume and sort of do the full integral. So I'll kind of leave it up to you. However much you want to do is fine with me. So that was 1A. 1B, just keep this going. The region bounded by y equals 2x, y equals 0, and x equals 4, rotated around the y-axis now instead. So let's do another sketch. I'll shift this up so you guys can see. So this is another quadrant 1 region. I think actually, now that I say that, sort of talking and sketching at the same time, I don't think we did any regions except quadrant 1. Part of that is, if you cross over an axis and then you rotate around that same axis, you get a weird overlapping thing that happens. So that's a little bit strange. If you're rotating around another line, around something that's sort of away from the axis, you could, in theory, do something where you're kind of crossing over without any issues. In any event, this is y equals 2x, going from, so out to x equals 4, and then the bottom bound is y equals 0. Oh, 2 times x, so that's going to be what? It's going to go up to 8. These are all tall. 2, 3, 4, 2, 3, 4, 5, 6, 7, 8, 10 is up here. So that's 5. Something like that. This, of course, so that's y equals 2x. X equals 4 is here. My graph. All right, so this is kind of our region. You're probably going to say to yourself, that looks like the slope for y equals x, but you just said it's y equals 2x. My x and my y-axis are scaled very differently here because I wasn't plotting out very carefully before I started drawing. So there's a little bit of a lesson in there. Maybe look before you leap, right? Actually, like, plan and try to do a good job when you're making sketches. In any event, this one is rotated around, so it's this region. If we went around the x-axis, this would mimic and be almost the exact same kind of setup as the one we just did, but twist, or should I say rotate. Oh my god. That's horrible. We're going around the y-axis now. So if we're going around the y-axis and we're given, right, a y equals style function, probably what's going to be best here are shells. That's kind of just generic advice, but it holds up pretty well, I would say. I think it's generally true. You could do a discs. I guess technically it would be a washer's version if you sort of looked at it, right? If you shifted your orientation and did it as an outer and an inner and just sort of, solve for these different values, you would need to sort of resolve this as x equals 1/2 y. Well, here, let me do the shells version first, and then maybe if we've got time, I'll do a quick setup with the discs version as well. So the shells set up, right, our volume should go A to B, 2 times pi times the radius times the height with respect to x, right? So we've got two different things when we are thinking about kind of doing the rotation. What we're doing, right, is picking an x value, and then it's getting rotated, right, to create our shell. Something kind of like this. So you've got the radius and you've got the height. We've said usually, right, and this will be true for us here, the radius is often the x value. The height is usually our function value here, right, which would be in this case, the y equals 2x. We're not sort of going between two curves or anything, so this is all good. The interval that we're going over, the x interval goes from 0 to 4, right? So this is from the x perspective, so the interval was an x interval, so that's 0 to 4. 2 times pi, the radius is x, times the height is 2x dx. And that would be the basic setup. That's enough. I mean, that's good. If you wanted to start to clean it up a little bit, you know, you could do something like take this 2 pi out of here. 4, this would be x and x, 2x squared. I guess in some sense this would maybe be 4 pi, right, times x squared. That integral would be fairly standard, would be fairly simple, not really a huge deal to take that and keep going. So that's definitely something we can do. All I want for the quiz is the setups, but kind of knowing we could continue and find the volume is good. It's good to be able to do that. An alternate version here, right, if you wanted to do a washers style, we're going to need x equals type equations, right? And so what happens here is y equals 2x becomes x equals, you know, 1/2 y, what would essentially be y divided by 2. And the idea, right, is if you're looking at it from this perspective and trying to set up a washer, you have an outer and an inner radius. So this is going to be washers. So the volume here would be, right, a to b pi times your outer radius squared minus pi times your inner radius squared dy, right? This is now with respect to y, so it's a y interval. The outer radius is just the upper, which is just the line x equals 4. It's set up as an x equals, right, which is what you'd want. The inner is the actual curve, or in this case the line, x equals, so that would be 1/2 y, or, you know, y over 2. So the volume here, what we're going to get is, along the y-axis, this goes from 0 to 8, right, on the y interval. So 0 to 8 pi times 4 squared minus pi times quantity 1/2 y squared dy. So that would be the setup to get the volume using a washer's style integral. You know, 0 to 8, you know, pi times 16 minus whatever, pi times 1/4 y squared dy. Again, you know, either of those two setups works. Either of those is fine. But that's the idea. So it's in theory, whichever version you prefer. I kind of like, and I think in general most math professors would say, you know, go back and forth between shells versus disks and washers, so that you kind of have to do the least amount of rearranging and you sort of get the cleanest integral. This is probably a cleaner integral than having this. Not that this is crazy, but it's obviously a little bit more work and a little messier. This is pretty straightforward. I didn't do that for the first one. I kind of temporarily forgot, but also just to sort of acknowledge that setup, if you did this from the y perspective and started to try to set it up as shells, it's going to be more complicated. You're going to have a region from 0 to 1 that just is a constant function going from 0 up to 3, and then from 1 out to 10 you're going to have to set up, right, the height value is going to be the difference between 3 and then this guy rearranged, right, the root of y minus 1. So there's a lot of different things you need to set up there. I'm kind of skipping it. It's very obvious that this works nice as a disk, and there's obviously a lot more work that goes into it to set it up as a shell. So I kind of skipped it there just because it's very clear that the disk option is best for the first one. For B, you could in theory do either, so I've got them both here. You don't need to do both, right? Whichever one you think is the better setup, go with that. All right, we'll catch you in the next video for parts C and D.